all kind of gave up, and a few students persevered, including myself and Paul Allen. And so, we sort of got addicted. We fell in love with this messing around with this computer, trying to get it to do things. Even in those days, the vision of what computing could do was very expansive. In fact, down at the Stanford Research Institute, in 1968, they actually built Shaky the mobile robot. It was able to move around, lift blocks, it had vision. It's kind of funny today that we're still on the verge of, will there be this type of self-propelling robot? Are there applications that it will be effective in? I was meeting with a number of startup companies this morning, still trying to crack that market. So it proves that although science goes very quickly, sometimes the challenges we take on are very difficult. The Shaky could see those blocks, but of course that was a very self-contained, well-defined environment that it was able to operate in. A lot of this AI work and the ultimate dream of software goes back all the way to 1950 when Alan Turing created the idea that we should be able to match human capabilities in many ways. And AI has gone through a number of boom and bust cycles since then. You'd have to say we're in a boom cycle right now, although there's some very profound things like being able to read and understand text and material like a human does, that we actually have no idea how to solve that problem. And it's sort of the next on the agenda and very hard to predict when we'll get there. Even so, the machine learning tools that we have today are going to be applied in a broad range of domains, including modeling disease, finding drugs for disease, understanding biological systems. And so it is a very exciting time. The capacity to execute those AI models is doubling more than once a year. So we're going up even faster than so-called Moore's Law by building these very special purpose things to execute both the creation of deep learning models and the execution of those models. And so applying those in a broad way and really understanding where they're applicable, that data revolution is here today, and it's suffusing itself through many, many problems, including these health problems that are so critical. We also have recent breakthroughs like the gene editing technologies, including CRISPR. And so, we should be able to use that for very low cost point of care precision diagnostics. We should be able to use that for therapeutics, and we should gain understandings of how to do vaccines, even vaccines that the turnaround time, instead of being the typical 3 or 4 years, literally at some point we'd be able to create in months. And we want